Excellent. Thank you, Alex. And we've got a lot coming up. So may I invite Martin Schichtel from Kraftblock to present. Kraftblock is a very innovative company which deals with thermal blocks made from recyclable material. So over to you, Martin.
Yeah, very good. And thanks a lot for the introduction. Greetings from Germany and a good afternoon to all of you out there. I'm really excited to start this lineup of amazing tech companies in the clean tech space. As you said, we need all the opportunities in the market to get to tackle the climate change. So we should work together to a common goal for the future. I'm Martin, founder and CEO of Kraftblock. I'm really happy to introduce our successful technology to you today. If I'm going back to the very beginnings of our technology, actually, I would say we strongly believe that we need innovative and new and future-proof approaches to tackle the world and the problems of our past. Future-proof because we also have to solve some problems that might occur in the future. So we should have the best setup already for today. That's why we started, and you already mentioned it, developing a new type of storage material first, integrated it in a modular and easily scalable storage device, which then is encapsulated by the heating system and the discharging system as well, to deliver what we call an integrated storage solutions to our customers. So the customer just would see a big box with the integrated full system to be charged, stored, and to be discharged. At the moment, we can serve industries up to 1,300 degrees C of process heat. And I'm pointing it out at the moment. There's much more to come in the future because there are some opportunities. But we said, well, standardizing the storage below 1,300 degrees C and having the economies of scale is much easier than having special applications for higher grade heat as well. If I would jump into our setup and a very brief overview on how we think, on how we act, the customer would see the blue box. And in the blue blocks, we split it, storage from charging, from discharging. So we removed all the components outside of our storage because of a couple of reasons. The very first reason is we have a storage platform, right? So we're using exactly the same storage for multiple applications. As there's no part integrated in the storage, it's easy to scale. Put 2 boxes together, put 10, put 100 boxes together. You can do it without rethinking the whole storage system as well. Having this flexibility, we can select to go for waste heat recovery, power to heat, so using the electrons, or even go for concentrated solar power, in this case, to charge our storage device. More or less the same for the discharging system. Well, what type of heat does our customer need? Is it steam? Is it hot air? Is it thermal oil? It doesn't really matter because there are solutions in the market that we can mix together with our storage to supply this to the market. And I might point out to you, you already talked during the introduction about electrification. That's true. Electrification is the future, but as for the moment, 90% of the customers are running on waste heat, right? And there are large-scale customers which should make use of the waste heat before they can electrify, either because of grid constraints or even capex investments to electrify, for example, a full steel plant at the end. What are the advantages of the solution? We developed our own storage material out of a couple of reasons, because we are able to use up to 85–90% of recycled materials. So also taking a look to the life cycle assessment, taking a look to circular economy at the end. But we are able to tailor heat capacity, heat conductivity, and a couple of more parameters. Means we set a new material basis that can be varied for the future for different applications as well. So we even could, if we would, love to tailor the storage material for one specific customer, if there would be the need to do this. This is also meant by the future-proof materials design. At the moment, we are talking about capacities like 1.2 megawatt hours per cubic meter. Development for a much better material already is done. We are just now testing this material. So as I said, much more to come. And we tested the storage material as well as the whole storage system in very harsh environmental conditions. Means you will never find those testing conditions in real life. So we made it as worse as possible to see what the lifetime of our storage is. And we are talking about 30 years plus. So tested the whole thing for 15,000 cycles without any degradation of the storage material itself. This integration in this storage system, the platform approach, gives us and especially our customers a couple of more advantages and USPs. So we have this modular and flexible design, right? We use the same storage and decide for each customer what is the charging system, what is the discharging system integrated. By doing this, we have more opportunities, means our system cannot overheat or cannot create hotspot because we split the components. We even can encapsulate the components in terms of safety. What is much more important for our customers at the end is maintenance, right? The OPEX of such a system. CapEx invest is one thing, but we have to think about service life of 10 years, 20 years, 30 years. OPEX is the major thing for the future. By having the split of the components, all the components to charge, discharge, storage are easily accessible, right? So you can just give you one example, what we designed for one customer, electrification, so getting rid of fossil-fired system and replace it against the electron. We designed it that way that we usually would fully charge our storage device during the standstill time, remove the heaters, do the maintenance at the heaters, which you have to do, insert the heaters again, and while you're doing the maintenance, you already can discharge the storage device. So we minimize with our system the downtime and increase the availability. And that's pure money for the customer at the end. And that's the beauty of the setup that we selected and that we offer to the market as well. Let me show some examples. You pointed out some of them in your slides. Probably most of them are not known in the market yet, but we are operating a couple of systems already since 2020. On the left side, it's a project in the ceramics industry here in Germany, waste heat recovery unit, 4.2 megawatt hour storage in a 10-foot container, so a quite small and compact solution, with the effect for the customer saving something between 15 and 20% of his primary energy every year, saving carbon dioxide, of course, avoiding carbon dioxide, and even increasing the quality of the ceramic products they are producing just due to a very specific discharge of our storage system. On the right side, inside, it's the same. The container in this case is green, and we developed a new type of, let's say, packaging, because this customer owns a fleet of 80 of those trucks. That's a mobile system, which is even more challenging because you have vibration frequencies, you have the truck drivers, which are not the very sensitive persons in the world, which lift the storage on the truck, put them down on the floor with mobile coupling stations, which enables us to provide even flexible heat or district heating system in a kind of 2-point district heating system. Both of the customers are happy. We are already in the execution phase for the rollout of those storage systems with those customers as well. As for this year, we'll have the commissioning of 3 larger systems. The biggest one we are talking about, probably you also know, is the one with PepsiCo in the Netherlands. Eneco is the energy supplier in the food industry. Major goal was to replace a 25 megawatt gas-fired boiler against renewable electricity. So we selected a special setup to charge the system within 4 hours, but deliver 24 hours to the PepsiCo heat demand. These are 2 stages, 70 megawatt hours are deployed this year, and then we extended to another to 150 megawatt hours to cover the whole production site in Brock-Klangendijk. Then we have 2 projects in the steel industry. One I love very much, it's flare gas utilization. If you pass by oil and gas companies, if you pass by a steel mill, you have this wonderful large flare gas stack just firing atmosphere purely into the atmosphere. We are able to recover it, directly charge it into our storage device, going up to 1,200, 1,300 degrees C and reutilizing it. What you can see on this slide is just the pilot, so the proof of concept that all those technologies are working fine, but there will be a larger system to come. On the right side, this is also a project, steel industry, with one of the largest Indian steel producers. It's in the final phase of its erection now. A small storage device, 20 megawatt hour storage device, also waste heat recovery, but this small system increases the efficiency of the sinter plant by 2%, which means at the end 40,000 tons more to be produced using just a small energy storage. So small storage system, but with a huge impact. At the end, from all those discussions we had in the market with our customer, we designed 2 standard modules, which can be easily adjusted to the customer needs. So we have a standardized system, but on the opposite side, we also offer customized solutions because of this modularity and flexible approach that we have chosen to cover the needs of our customers, which ends up having a very strong sales pipeline we want to deploy over the next years with 2 types of business models, typical sales of those components, but also energy as service. And I think I'm just good in time, and I'm looking forward to your questions. Thank you.
Great. Excellent, Martin. That's really inspiring, and a well done to the team I think we've got time for just one question, and I see one coming. What caused you to focus particularly on the higher temp applications, and that some of the deals that you're working on actually are called more the medium temp? So if we could do that like in a minute or so, that would be great.
But that's a quite simple answer. Everywhere where you operate a furnace or a kiln, you have high grade waste heat, 1000 degrees C or even higher. Usually you don't utilize 1000 degrees C directly, because then your storage would be impressively large. So you try to get a maximum delta T in the process to have the most useful capacity.
Fantastic. Fantastic. Well, listen, Martin, that was brilliant. Thank you very much. Thank you very much.
Thank you.